Okay, guys. So today we're going to talk about test classes, and if we have time, we will also touch base on governor limits. So, is everybody able to see my screen? Okay, let me come back to this. Okay, and if you guys are not talking, you can keep yourself mute, and if you have to talk, just unmute yourself. So first of all, why do we have Apex test classes? So you have to test your code before you put your code in production. When I say production, the real customers are going in, they're buying stuff or whatever they're doing, they're using your services. So you don't want to put something that will break the existing features. So it is very, very important to test your code. Besides manual testing that is available, a QA will do it on your code or a team member will do it, or it's important to write test classes. So Salesforce has introduced this concept of test coverage, and your code basically runs in a multi-tenant cloud. Multi-tenant cloud means your resources are being used by other tenants, so you cannot monopolize those resources. Means you cannot just go ahead and kind of take advantage of everything and not and don't leave anything for the rest of the tenants. So it's very important, and that's why Salesforce has put some checks that everybody should follow and has put some governor limits. And if you cross those governor limits, your code will end abruptly. So it's always mindful and important not to cross those governor limits. So since the code runs in a multi-tenant, your deployment, whatever you are pushing to production, should be safe and predictable. Means it should not break anything and it should not break your existing features. So in order to push your code to production, the you need at least minimum of 75% code coverage. I say minimum of 75. A lot of companies go up till 95%, 98%. So at least minimum is 75 set by Salesforce, but it varies from company to company. And some companies don't even wait till production to have the code coverage. Some companies will put it into a higher sandbox as well, that you need to have code coverage so that you don't wait for the last minute to get the code coverage. Okay. So what a good Apex test actually proves. So whenever you are writing test classes, okay, whenever you are writing test classes, you have to make sure that your code does not only just do a line coverage. Line coverage means people just go ahead and have workarounds where they will not add some spaces, or they will try to reduce the number of lines. So they'll kind of go about it, and they'll try to cover the code, but they won't have assert statements to actually check if the code is working as expected or not, which is not a good practice, but just a workaround a lot of developers do follow, which is not recommended. So whenever you are writing your test, you should validate the data is created, updated, and deleted correctly. You have to validate that. You need to validate business rules are being followed. You need to also think about edge cases. Edge cases means might not happen in normal, but it might happen. Let's say if you're making a call to an external system and the service is down, what do you do? If an exception comes, what do you do? So you have to cover edge cases. You have to think of asynchronous jobs to fully finish, callouts returning you proper mock responses. So that's how you have to write your test class, and your test methods should cover all these. So in order to there are several methods that are available in the system class, like system.assert, system.assert equals, assert not equal. So assert basically checks whether two things are true. okay, whether the statement is true. And if it results into false, then you basically going to get an error. The test will fail. Assert equals will check if the two things are equal. If it not, then it will give you an error. The test method will fail. If two things are not equal, that's what it will check for. And if it's not equal, good. If it is supposed to be not equal and it ended up being equal, then you're going to get an error. Okay. Now, the next is test usually runs in an test should run in an isolated context. What does that mean is that you should not depend on your org data for your test classes. So test classes should not be depending on your org data, because what if you move from this org to the new org, that test data was not there in the new org, so your test cases will start to fail. So you always should create your own data when you are writing test classes. That way, you are not dependent on the org data, and also it makes your test repeatable and reliable. Means your test case will not fail from one org to the other. But if you had used this annotation called see all data, which is a bad practice, so if you're using that annotation, see all data, what it does, it basically uses your org data. And what happens is if you have this annotations, the test will become dependent on your org records. And when the org data will change, means you move from one test org to the another, those tests can fail and deployments become unstable. So whenever you're writing test classes, you also need to create test data, and it is highly recommended. Okay. In very rare scenarios, you can probably use test data, or you can rely on your org data, but it is not recommended. And test methods run with the same governor limits as normal Apex. So just like in Apex class, you have governor limits, your test classes will also have the similar governor limits. And but there is a thing called start test and stop test. Basically, this resets your governor limits. Okay, so whenever you are writing a test class and inside of the test class, you write your piece of code within these start test and stop test, they give you a new set of governor limits. It resets your governor limits, and also make sure that if you're invoking any asynchronous code, it finishes before it hits the stop test. Okay, so those are the two benefits of using start test and stop test. Start test is basically going to reset the governor limits for you. And the second thing it will do is if there is any async operations that are running, it will finish those operations to make sure you get the result that you're expecting. And so the current pattern that you have to follow is you create the data, then you will write start test, then you will call whatever methods you want to invoke, then you will use stop test, and at their last, you will have assert statements to check the expected output equals to the actual output or not. Okay. Now, how do you, so far, any questions, guys? No. Okay, good. So how do you first of all uh, write a test class? So you will use certain annotations, okay? And one of the annotation basically is called as is test. You can see here, this is an annotation as at is test, which basically tell you that this is a test method. And if you are setting up some test data, as I mentioned to you, you have to set up the test data. Then in that case, you will use this add test setup, which basically creates a reusable test data one time, and other methods can automatically use this test data. So you don't have to create data for each test method. So there are multiple ways of creating test data. One option is to create one method in the beginning where you create all the data that you need for all the methods. That is one way, one method where it is creating the test data. The other method is within each of the methods, you are creating the data, which is not a good practice. But if it is one or two records, you can do that. And the third option you have is you create a separate class, and inside of this separate class, you create all the test data, and you, from your test class, all you're doing is you're just invoking this uh, factory class, which is creating the records, and then you are running your test methods, which is one of the good practice, is to have like a data factory which is creating all the data, and then from your test classes all you're doing is calling these data factory and reusing those records that it has created. That way your test classes will be more simpler and easy to write. Now, you also, whenever you are writing test methods, you all know you have to have a method where the data will be set up. Then you have to check for happy path. Happy path is basically, is it working good or not? That is your happy path. Valid scenario works or not. Then you also need to check for negative scenarios. You also need to check for bulk records. Hey, does your code works for more than one record at a time? And also if there is any edge cases, you should check as well. So these are certain, when you're writing test classes, these are some of the best practices to follow is, okay, write a code to test an happy path. Then you're going to write a code to test a negative scenario, then for bulk records, and then edge cases. So these should be your test methods that you should have when you're writing test classes. Okay. Now, the test setup method is basically, you will have it one in every test class, and basically it inserts the records that will be used by all the different test methods. Okay, the benefits is you don't have to recreate test data in every method. You create it at one spot, and before running each method, that method test setup method will be called. Much cleaner code, consistent data across all methods. Okay, so anytime you have used test setup, that test data will be available to all the test methods. And in addition, if you want to add more data, you can do that as well using this. You can do that also where what is it called? You can have more data added, but you can actually create a test setup, and in that test setup, you will have all the test data created. Okay. So one of the way, as I mentioned, you could write a separate method, which is a test, which is annotated with test setup. And that method will have all the test data created, and all the methods that are there will automatically call this method before running them. In individual of these methods, you can also create test data as well. But if this is already there, it's better practice to create all the test data at once, and then all the methods will call and depend on that test data. Okay. Now, what are the best strategies for creating the test data? So, approach number one is you create the test data within each method. That is approach number one, not recommended, but it is, if it is only one or two records, you can do that. Okay. Create records inside each test method. And if you just, if the test is literally a small one, if you need just a couple of records, you can do that. The second approach is you have a test setup method, and you will basically create all your data inside of the test setup. And inside of the methods, you will query that data. That is a good approach. And this third approach, which is one of the best approaches, is you create a test data factory, and inside of that, you create all your test data. And you basically, inside of your test methods, all you're doing is querying and testing if it is working as expected or not. But the creation of the data is happening in a separate class, okay, which is your test data factory, and which is one of the best practices to do it. Now, let's go ahead and do an example to illustrate how to write a test class. Okay, any questions up till this point? Okay, So I have a class here called discount service. So let me go ahead and log in. So I'll go to login, and here I'll go to this org. Okay, and inside of this org, so I'm creating a class, okay, and for which we will write a test class. So the name of the class is called discount service. It is the name of the class. And this class basically has a method, and let me just go ahead and copy this whole thing. Okay, so now what is this class doing? So first of all, we do have created a custom exception, which is called as discount exception. It is a custom exception because it extends from the exception class. And then you have a method called apply discount. And what does this method does? It basically applies a discount, okay? And you pass in the amount and how much percentage you want to apply the discount. Okay, so if the amount is zero, or if the amount is null or percent is null, you basically it will give you back 0 and 0. Otherwise, it will give you back the exact amount or percent. Okay, so you're checking what is the amount that has been sent within this method. And if the amount is null, you get 0 value for this amount. If it is not null, then you get the actual amount. Similarly, it is checking what is the value of percent that you're sending in the method. If the value of percent is null, it will give you back 0. Otherwise, it will give you the actual percent that you sent. And if the percent is less than 0, means minus 1 or 2, or greater than 100, 105, then you will get a exception saying discount percent must be between 0 and 100. And if it is okay, if it is 50%, 60%, then you're calculating the actual discount by multiplying the amount with percentage, dividing it by 100. That is the final amount that you will have to pay after you have applied the discount. Okay, any questions in this particular method that we are doing?
No.
Okay, so for example, if in this case, if I go ahead and call apply discount, and if I go ahead and give amount is 100, percent is 20, what will be the output? How much will be the discount? What will be the output here?
The amount is 100 and it'll be 20% of 100?
Yeah, so what will be the return value?
80?
Very good. It's going to be 80 because first it is calculating the discount. Discount is equals to amount, which is 100 multiplied by 20, which is 2000. And this whole thing is divided by 100. So 2000 divided by 100 is equals to 20. So discount is 20. So the final amount would be amount minus the discount, which will be 80. Okay. So now, how are you going to test it? So the way to test it is, first of all, we will write an Apex class. Write a test class for it. Okay, so let's say we call this as discount service test. So here, this is an Apex class. And this Apex class should be private, okay, because usually all the test classes are private. And let me write down this thing. Okay. So over here, the list of some exceptions, list of some annotations. So anytime you're writing an Apex class, it always should be annotated with @isTest. Okay, that means it is a test class. That is what is the most important thing. Then a test class should be private. Ideally, it should be private, and you should have some kind of naming convention when you're writing a test class. So let's say our class name was discount service, so the test class will automatically would be discount service test, so that any developer who is looking at this class, they know which Apex class this test class is for. If you write it a completely different test class, the person won't be able to figure out which Apex class this test class is for. So it's always important to have your main class in the name. And now here they're using, they haven't, what they're doing here is they're not creating any separate test data. Okay, so they have a method called @isTest. Okay, and inside of this isTest, they have created certain methods. So all the methods should also be annotated with isTest to tell it's a test method. And this is the name of the method, and it tells you this is the happy path. Okay, so here the amount is 200%, is 10. The discount is, so what they're doing is they are checking, since it's a simple method, they are checking they're calling the discount service dot apply discount method, and whatever the result is, they're using the assert statement. Okay, assert equals, hey, is the amount equals to 180? And if it is equals to 180, you are good. If it is not, then it will give you an error and the test method will fail, and this would be the error message. So assert equals basically test, is this result equals to 180 or not? So this is the expected and this is the actual. So it will check, hey, does these two values equal? And if these two values are equal, we are good. The test method will pass. If they are not equal, then this will be the message that will be thrown and the test method will fail. Okay. So this is how you create a test class. You first annotate it, make sure it is @isTest. The methods will also be with the annotation @isTest, and the class would be private. And then you will check for different cases. So here it is checking for the happy path where it is giving you two values. Then it is checking with those null handling. Okay. So first in the amount is null, then it should give you the result should be, if you remember, it should give you result as 0, right? That's the check we did in the discount service. If it is null, then the value would be 0. If the percent is null, the value would be 0. So here it is first putting the amount as null. So actually it should be treated as 0, and 100, then percent is 0. So then it will be 100. And then if both are null, you should get result 3 should be 0. So these should be the actual results. And if it is checking, hey, is result 1 equals to 0? If it is equals, we are good. The test method passes. Otherwise, this is the error message that will be thrown. So you have assert statement. A lot of time what developers do, they will call these methods, but they will never have an assert statement to check what is happening. So that is a bad practice, but as a good developer, you should always write assert statement, because that is the point you will know if your code is working as expected or it is going to result into any errors or not. Now, the final one is to throw an exception. Remember, you want to also cover this particular line as well. So in order to cover this line, what they have done is they are giving the amount as 100 and the percent they are giving is 150. So when the percentage is more than 100, this is the exception that is thrown. And this is how you can check. So it is checking system.assert false. So if it is giving you false, then that means the exception discount was not thrown. And ideally, it should throw an exception. So you're checking, was this exception thrown or not? So assert statement checks if this value, these two is true or not. Okay. So if it is not true, in that case, the test method will fail. And here it is checking, then exception will be thrown, and then they have added a catch block to catch the discount exception. And inside of this, they're checking they're checking what is the message that has been thrown. And if you see here, this is the message, discount percentage must be between 0 and 100. So it is going to check, hey, if the message contains this value or not. If it contains this value, we're good. Otherwise, this is the message it will throw. Okay, so is this resulting into true? Yes, it is resulting into true. If it results into false, then what will happen is this is the message that will be thrown to the user. Okay. Any questions, guys? Can I get a thumbs up from everybody? Are you guys following me? Hema, Jay, Kushbu, Ram, Shalini, Shweta. Awesome. Okay. So now how do you test it? So the way to test it is you go to test, you will do new run, and then here you will select your test class that you want to run. So here discount service test is the class I want to run. And you can see these are the three methods. So whatever the methods of the test class, you will see it here. So there are three methods. So all these methods will appear. Okay. And then you will click on run. Once you click on run, you will come over to this test tab. Okay. And it tells you that at this time it was a test run and this was the test class, and it will tell you which all methods passed. There might be a possibility that some methods may fail. And right now it tells you that all the methods have passed. And if you see it on the right hand side, you will also see the code coverage. So if you go here, discount, this is alphabetical. So if you see here, discount service, it is 100% covered. So if you double click on it, you will see that the classes which are in blue, that means they have covered those classes through the code coverage. Okay. And anything that doesn't have the line, that means that line has not been covered. And as you can see here, the complete class has 100% code coverage, which is good, and you can check it. And if any case the method failed, the percentage will reduce and you have to fix it in order to get that code coverage. Okay. So what do? Test, new run, select the test class, select the methods you want to test, and then hit run. Now this was a simple class.
Deepika,
Yes.
sorry. Does it also show the governor limits and all?
No, it doesn't show the governor limits.
Okay, so anyway, we check even those things.
Yes, I will talk about that. There is
Okay.
a class called limits.
Okay.
Inside of those limits class, you have methods where you can check if the governor limit has been crossed, how much we have achieved, all of that.
Okay.
Okay.
Yeah.
So now coming down to the next question we have is the account DML service. Okay, so this account DML service, let's first understand what it is doing. So first it will create the accounts based on the names. So if you give multiple names of accounts, it will end up creating those accounts for you. And then what will it do is it will update the type of those accounts as customers. So let me first see if account has a type of customer or not. So let's understand that. So if I go here, accounts, type, it has customer direct. Okay, so let's see if this works. So let's go ahead and copy account DML service. File, new, Apex class. And this class, let's first do what it is doing. Okay. So now here, Okay. So inside of this, we do have a custom exception created called account service exception. And because it extends from the exception class, which means it is going to give you a custom exception, then you have a method which is called as create accounts. And this method takes in a list of string, means whatever, if you pass in Titan, Webull, Robinhood, etc., it will take those list of names. And first it will check if the names are null or if that list is empty. If it is empty, it will right away throw an exception. Basically, will say account name list cannot be empty. But if it is not empty, then what it is going to do, it will iterate over all those names one by one, and it will check if the name is blank or not. If it is not blank, then it will go ahead and created this empty list, and inside of this empty list, it will add those account records. And once it has added those account records, it is doing a one single DML to insert those accounts. This is one particular method of this class. Okay, so to this method, you will pass in the list of names. And first it will check if the names is empty or if it is list is empty. And if the list is empty, what it is going to do, it is going to give you an exception. But if the list is not empty, it will iterate over all these names one by one, and it will check if the name is present. And if it is present, it is going to add it to another empty list here. And then it will go ahead and do a simple insert onto those, and it will insert those account records. Now, updates the type to customer for given account ID. So then what it is doing, it is going to have another method called mark as customer, and it takes in the set of account IDs, and it will query those account records, and it will set the type to customer. Let's do it to customer direct. I believe this is the value, but to be honest, let me first get it from here. Edit object. And here we will go over to fields and relationship. We'll go over to type. And inside of the type, we will scroll down and we will go to customer direct. And here we will replace it with customer direct and hit save. And then it is going to update the type. So in the one, it is creating the accounts, and this one is updating the type as customer direct. Now we will create a test class for it. And the test class is called as account DML service test. Okay, now here, let's go. It has to be private. So I'm going to go ahead and get the code. And now somebody needs to explain to me, what are we doing in this test class? Okay, so, and then if you didn't understand it, I will explain to you. Okay. So inside of this, what's going on, guys? Can somebody tell me? Or do you want me to just start? Anybody wants to take a shot at it?
We are adding the 3 names in that string list as
Very
a
good.
test. Okay, and then we are checking it after that if it is asset equals so. Okay, so how many records are really inserted? If it is 3, that means we successfully inserted those 3 records, and then we are showing those names inserted of 0.id, that it will show the.
No.
Oh, sorry. If it is not having ID, then it will show that it is, if that ID is empty or null, then it will show that inserted record should have that ID. So we will then after that, like we did there, updated it with the IDs. Here we are passing 3 IDs and then adding for that account, we are adding a ID or updating the ID.
You can't update the IDs.
Inserting those IDs, right?
No.
No. We can't insert ID.
What is inserted? What is inserted is
Names.
create accounts.
Yeah.
So what will this list have? So if you see here, it is returning you, if you go
ID
back,
and
it is returning you that list of records it inserted.
yeah.
So those list of records will
We'll
also
have ID and name.
Yeah, exactly. We'll have ID and name.
Yes. So if it is empty, then it will throw the exception that ID cannot be empty, else. And after that, okay, that is done. Here we are checking if that 3 names, whatever we are inserting, if it contains those names.
Yeah, exactly.
Yeah.
So let me iterate it one more time here. You pretty much covered it. But first of all, we are creating an list here, and these are the 3 names we are adding it to the list: Acme, Globex, and Initech. Okay. And here you can see the create accounts. Now this create accounts will go and invoke this method, which is the create accounts. And here you are passing in the list of records. And what it is doing, it is checking if everything is good. If it is not empty, we will go ahead and insert those records. Okay. So it'll go ahead and insert those create accounts. And then it is checking assert equal. So it is checking what is the size of the list that it returned back. So it will return you back the IDs and the names of those accounts. And we are checking if the size is 3. So this is expected. This is the actual result. Assert equals, hey, is these two equal? If it is equal, the test case will go to the next line. Checking, hey, and if it is not equal, then this is the error message that will be thrown. Assert not equals means inserted 0.id. This will give you back an ID. Okay. And this is null. So both of them are not equal. That means this also assert statement passed because we are checking for not equals. Then what we are doing is we are basically checking, did each record got inserted properly or not? So here we are iterating over all those inserted accounts, and we created a set of IDs with all the newly created accounts. And then here we are querying those accounts again. And then we are checking the size. Hey, did those 3 accounts got retrieved? Okay, if it got retrieved, assert equals 3 is good. Then we are checking if what is the name of those accounts. So the first name should be Acme. Second should be Globex. Sorry, it is only checking the contains. It's not checking with the index. So it is checking if it contains Acme. If it contains good, so true, true, true. If it's true, it will pass. So this is your one method. Now in the negative one, it is checking for throws exception. So you can see here in the list, it is passing you an empty string. Okay. So you are doing a start test and then you will create accounts. So in this case, what will happen? An exception will be thrown. So if you see here, if it's an empty string, you can see here, if the name is blank, then account name cannot be blank. That is the exception you are throwing. So if that exception is thrown, then what will happen? The catch block will get executed and it will check, hey, if the assert statement contains this message or not. And if it does not, then you will get this show throw beautiful validation message. Okay. And then here it is checking, did it inserted partially, because good name was correct, right? But now none of those records will get inserted. Okay. So ensure no partial insert happens. So if it basically should be 0, so no record should be created with the name good name. And if it did, that means there is something wrong with the data or with your code that it actually ended up creating that account. Okay. And then it is checking the second method. Everybody understood this one, what it is doing? So one particular list was a happy path. You passed in all the three. In the second, you passed it an empty string, and here you're checking for exception. Okay. And the third one, you're checking the updating the customer type. So you are basically creating two accounts, one with the name type test 1 and the other one is the type test 2, and you're inserting those accounts. And once those accounts got created, you basically created a set of IDs with those IDs of those accounts. And then you are calling this method called mark as customer, and you're passing the IDs of those newly created accounts here. Then you are retrieving the type of those accounts, and if it is it will return you two records, and you're checking, hey, is this returning me two records? If it's good, we will proceed to the next one. And then here you're checking, see, now this should fail because our value is customer dash direct, and here we are checking only against customers. So I'm assuming this method will fail, and I will leave it as it is. I won't make any check. And then here it is just checking for the exception, if the exception was thrown or not. So this is another method. And if I scroll down, I'll explain to you these two methods, but let's first run the top three methods that we have. So here I'm going to do test, new run, and I will choose the account DML service test, and I will choose the first three methods, blank and updates the type. Okay, and then I'm going to go ahead and hit run here. And let's finish it. And you can see two methods are successfully passed, and this method will give you an error. Okay, so it will tell you what was the error. So it says update failed, first exception on row 0. Oh, this is giving you another valid select SLA tier for the customer. SLA tier for the customer. We also need to, in the line 43, mark as customer, DML line 43. So what will I do here is I'll go back to line 43, and here also I will set up SLA tier. So we'll go here. Let's go to the SLA tier, and this is a pick list. So let's select the value here equals to, and we will select a tier as well. And let's say we select gold. Okay, so we're going to select gold and then enter it. And now I will run the test again. So debug, clear, log panel, and test, clear test data. Okay, so now here, test, new run, account DML service. What is it? Insert records, throw, and this one. So let's do a run here. Okay, again, the exception has been, error has been thrown, and it will tell you updates type, and it will tell you what is the reason. First exception, field validation region is required as well. So it requires a couple of things. Okay, so let me select one thing. Let me do one thing here. If I go and I go in here, okay, SLA tier and region. Okay, so I think. Okay, so let's do one thing also. Let's try to set up region as well. Okay, so we'll go to the region and we'll go over here, click OK. We'll go back here and A dot of region is equals to north. Okay, so now we will go to the new run and account DML service test, and let's just do all three. Click on run here. Okay, so you can see here, finally it gave you the exception that I was expecting, and it says type should be set to customer, expected customer, and actual value came as customer direct. So your assert statement is the one that is telling you that you are expecting a value of customer, but I am getting a value of customer direct. Okay, and that's why since it didn't match, it gave you the error. Did you guys understood what's happening here, guys? So how will I fix it? How will I fix this error? What will I do in order to fix this?
Add system.asset not equal.
Okay, one is that, but then what is the better way? I see it's expecting a value of customer. Actual value should be customer direct, right? So here I'm going to say customer direct. And now if I run this test, new run, account DML service test, and run these three, click on run. And if I go here, this time it ran successfully. All the records gone because it's expecting the value to be customer direct. It got the value as customer direct. In the previous case, what was happening? You were updating the value to be customer direct, but you're checking the value should be customer. So if both doesn't match, you're going to get an exception. Okay. So in this case, what we are doing is, are we using the factory approach here or no? Are we using a factory approach in this case? Or we are doing the insertion of the records in each of the methods? What was the difference between...
Factory have to be separate class, right?
Yeah, factory was a separate class or was a separate method. In this, we are not doing it that. We are creating records within the methods itself, right?
Yeah.
Okay. So now, before I go to the next one, let's me explain the last two methods. So here you have, see, whenever you write start test and stop test, it will reset your governor limits. So here I'm checking mark as customer and I'm passing in the set of IDs. But if you see here, the ID list is empty. There are no IDs. So if I go here and this ID list is empty, you can see that it is giving you an exception saying account IDs cannot be empty. So now in this case, system.assert means what will happen, exception will be thrown in this case. Okay, and what will be the type? It will be account service exception, and it is checking, hey, is the message equals to contains cannot be empty? If it is yes, we will be fine. Okay, so ex.contains true, so this would be true. And system.assert gives you false, means it will automatically basically throw an exception in this case. And now here, the second method, what we are doing is we are creating a new account, inserting that account, and then we have this deleting the same account. Okay, so we inserted an account, we deleted that. Now we are passing in the deleted ID. So that means that record will no longer be existing, right? Because you deleted that. Okay. So once you delete that record, again, the exception will be thrown, and here the catch block will be executed, and it will give you a message, no accounts found, and we will be good in the test case. So it will pretty much cover all the edge cases as well. It is checking for everything. So now if I go here and test new run, and I'd run all the tests, and let's understand what is the code coverage for the Apex class. So if I go ahead and click run here, and we go to this 1051, all the methods are successfully passed. And then if I go to the account DML, so which is right here, 95% code coverage. So pretty much all the lines were covered except this one line, which is the account name list cannot be empty. Except this one, everything was covered. So we got a 95% code coverage. Any questions up till this point, guys?
Deepika, when you run the test, at that time it shows running test synchronously.
Means right away. Or you can run it as always run asynchronously, means it will run in the background and you can continue doing other things.
Okay. Yeah.
Okay. See, in the case of when you run this way, and we do this, and then here click on run, it is running the test asynchronously. Okay, the result would be similar, it's just one is running synchronously versus other is running asynchronously.
Okay.
Okay. Now, let's understand how the test data factory gets used. A test data factory is basically a helper class that creates the test records in a consistent, reusable way. This keeps our test methods short and readable. So when you have a separate class which is creating the test data, then it makes it easy for your test class to be only consist of the things that actually testing. Okay. Now, without a factory, what will happen? If you don't have a factory class, you will be creating accounts, contacts, opportunities, all of them, you'll be creating it again and again. You will be setting up required fields, a lot of duplicate data would be there, a lot of duplicate, what do you call, the records will be like you are just writing unnecessary redundant code over and over in every test class. So what happens is when you have a factory, when you have a class which handles the creation of the records, you move the creation of the data into one class, and your test methods focuses on what actually needs to be tested and also your assert statements. Okay. Now let's go ahead and create the test data factory class. So here what we will do is we will go ahead and create a test data factory. It is just like creating any other class. And the sole purpose of this test data factory is basically to create the data for you. Okay, so here this is my test data factory. Now somebody needs to explain me what we are doing. File, new, Apex class, test data factory. And here we will create, this is the class.
Do it need to have this name test
No.
data factory always?
No, it doesn't have
No,
to.
right? Okay.
No. You can call it as test creation factory or some whatever you want. Okay. So here, what are we doing? We are basically, this class is only to create records. Okay. So you sometimes you might just want to create one record. Sometimes you want to create a bunch of records, and sometimes you want to create a list of records. Okay, so you want to create 100 records or 200 records. You can have different scenarios. For each of those scenarios, you have a separate method. Okay, so inside of this, one method is build account. Okay, and all it is checking that the name that you are passing to this method, is it a blank or not? If it is blank, then it is going to give a default name as test account. Otherwise, whatever the name you provided is good. But in this case, it is not creating the account. There is no insert statement. You see in the build account, there is no insert statement. Okay. All it is checking is if the name is blank or not. So you can see here, this is what it is checking. If the name is build account, it takes in one parameter name. If this is blank, then it will be test account. Okay. Otherwise, whatever the name you have passed. Then create account actually first calls the build account method. Okay. And if it is, so if everything is good, then it is going to insert that account. So it is only inserting one record. Then you have is the build accounts, which is basically what it is doing. It is taking in how many accounts you want to build and what is the prefix. So test account 1, test account 2, if let's say your prefix is test account or your prefix is accounts, account 0, account 1, all of that. So it takes in, it is first checking what is the count you're expecting. If you're expecting a count of less, if you are sending count as null or less than 0, it will default it to 1. Otherwise, whatever the count you're sending, we will use that count. Then it is checking the name prefix. If it is blank, then it is using test account as the prefix. If it is not blank, whatever you're sending, they will use it. Then here you are basically building accounts. You're not inserting them. Okay. And in the create accounts is actually where you are inserting those account records. So you could, I just kind of made it a little bit kind of like 4 methods. You could have done it in 2 methods as well, but just you probably will have some unnecessary methods, but you could have just done the testing and creation in one part. Similarly, build contact is just building the contacts, tying it to that account ID. You're passing in the account ID and you're tying that. If the last name is blank, then you're using last name as test contact. And then here it is the create contact, which will actually insert the contact for you. And then this is the create contacts, which will actually insert multiple contacts for you. And pretty much it. That's it. So it's inserting 2 types of things. One is accounts and the other one is contacts. So this is your test data factory. Now your main class is this one. The same one we are testing, account DML service test that we did, but this time we are using the factory approach, not the regular approach that we had. So here I'm going to go to the file, new Apex class, test data factory, and here it's going to be a private class. And here, so what are we doing? Pretty simple. So the same thing. So inside of my each method, I'm invoking the test data factory create accounts. Okay. And I'm saying create 2 accounts and use the prefix as type test. So it will create one account as type test 0, another one type test 1, and it is going to create those 2 accounts. Then it is checking, it is adding the account IDs of those newly created account as a set here in this IDs as a set variable. And then you are invoking mark as a customer method, passing in those IDs, and you are basically updating the type to be customer direct. Okay. Again, this is going to fail because I'm checking it to be customer. So I'm going to go ahead and put a dash in between and make it direct. So the method passes. And you're checking, hey, is the type of the customer that you create, is it customer direct or not? Here, you are not using the factory approach. Here, you are actually created a names as the list, and then you are using the create accounts method, pretty much the same we have it. So in this case, you're not using the factory. And in this method, we are basically using build account. So we are building the account, and then you are checking. So in this case, tell me, has the account been inserted or not? In this case, when you do build account. Guys, speak up.
Not.
It doesn't. It only builds the name. Okay, and as you can see here, I've also put a comment in there. It does only builds the name. If you look at the factory, build account is only building the name and checking. See here, build, was it a build account or build accounts? Build account. So just without an S. So if you go here, you can see it is just checking the name. If should not be blank. And if it is blank, it is calling it as test. So this is the prefix. Now in this case, the ID would be what? Null, right? A.id will be null. So this will be true. So no exception will be thrown, nothing. So this will pass. And then you're creating the account, which will actually create the account for you. And then in this case, the ID will not be null. So this is also going to pass. Okay. So this is how you basically use a factory. And inside of the factory is where you are creating the records. And inside of your methods, all you're doing is calling your actual logic. Nothing changes. So if you go here, new run, we will use with the factory approach. So nothing changes from your end. It's just the behind the scene, the methods are a lot more cleaner. So if you go here to the test, you will see this is your test data factory. And these are your methods. So here, these are the methods, happy, pass, clean, all of them passed. There is a checkbox next to them. And if you see here, your DML service is still 95%. So your code has been covered successfully with the help of test data. Now, there was one approach. The other approach is, basically you're using test setup. And inside of this, let me explain to you what this is doing. This is basically using test setup. And what happens with the test setup is before you call any test method, the test setup will run. So the test data will automatically be there. Okay. So let me explain to you. So here is the accounts with the setup. File, new, Apex class. And is test. So here, instead of manually invoking it, create accounts and all that, what I'm doing is I'm annotating that method with test setup. So when you annotate a method with test setup, before running any test method, this test setup will be called. Okay. So that 5 accounts will always be available. Okay. You don't have to write inside of each of the methods. The only difference between with factory approach and with setup approach is that in the case of the setup approach, you're not invoking it explicitly. You invoked it inside of the setup, and that is taking care. Here, inside of each method, you are invoking this test data factory. That is the only difference. So more cleaner approach is this. It is still calling the data factory, but only one method is being used where the data is being called. And then rest of the method automatically first will call the test setup. The test data will be set up for them, and then the method will be called. Any questions? Okay. Now, there was one more thing I had to explain to you, but the problem is the call out. Okay, so for triggers and everything, the test classes remains the same. The way to test it remains the same, except there is this, let me see if that postman is working fine or not. Let me give it to me 1 second. I wanted to check something. So everything is crystal clear about test classes, right?
So when you have number of classes, right? So test data factory, is it going to be one class with all the methods for every single classes, a single class that has
Single
different
object.
methods?
So let's say you
Yeah.
will have in the test data factory, you will have a method to create account, create test case, create cases, etc. So inside of your main test classes, all you're going to be doing is invoking those test methods from the test data factory.
Okay. And how about the setup?
So in the setup, if your test methods are only going to need account and cases, you will only call those two methods from the test data factory.
Okay.
Okay.
So, Dilka, correct me if I'm wrong. So the test data factory is only for creating the records, like
Yes.
inserting.
It is just
Other
the records.
Yeah, other remaining logic will be in the test class, right?
In-
It's only for
Yeah, it's only for creation so that you don't end up creating the same records over and over in every class where you need the test data. So it's better you create one factory class, which is just responsible for creating records, and you have a test class in which you will be calling those methods, and those will be, it makes your life easy and your test classes smaller to debug.
Okay, thank you.
Okay. So guys, I have to tell you something. It is not via the code because I don't have the code ready. But if you can, so everything remains the same for test, but if you are testing any call out, okay, if you're testing any call out, then you have to create a mock service. That means that your test class is not actually going to make the call to the service, to the actual external application, because what you will do is you will create a mock response and you will check, is the response coming back or not through this mock service. And you will basically will pass the code coverage based on this mock service response. Does that make sense to you or not?
So, will you be calling like actual API?
You
or
will be
not in the
calling,
mock
but
service?
the API
Okay.
response will be the mock response.
Mock. Okay.
Okay.
Mhm.
If you need an end-to-end example, I can do it tomorrow, because what happened was this morning when I was creating the example, this API wasn't working. So I have to, because the API key was brand new, so it didn't work, but I'll see if I can come up with a mock service example for tomorrow. But other than that, the test classes all remain the same. Your triggers, for your regular classes, it's pretty much the same. You will have different types of methods, test and start test, is test. These were some of the important annotation. Okay. So the next topic we are going to discuss before we move on is the governor limits. Any questions before I go to the next topic?
Deepika, will you have a test case on triggers?
It's pretty much the same. In triggers, you don't write
Okay.
the logic.
Mm-hmm.
And because as I mentioned, you will have a trigger handler class, and the handler class is just writing like a regular class, and you will have a test class for that.
Okay.
Okay. So if I covered each scenarios, guys, it will be first of all, too long, and second of all is redundant. I will explain the mock service one tomorrow because I think that's important. But other than that, I think we are good. Okay.
So in the previous example, you had the test start and the stop, right?
Yeah.
Somebody asked about the corner limit there. How
So
can we see that?
yeah, so the governor limits we'll talk about
That's
now.
good.
Okay. So first of all, let's understand what governor limits are. So governor limits are basically the runtime Salesforce at runtime, means when you're actually executing your program, at runtime limits, Salesforce enforces to prevent a single org or a user or a transaction from consuming too many shared resources. So since I mentioned you earlier, we are dealing with a multi-tenant environment. So there are multiple tenants. When I say multiple tenants, it's like an apartment building, right? An apartment building, you have hundreds of tenants living, and you have shared resources, you have shared what you call is the water, heater, etc., right? So similarly, in order to prevent one particular tenant to misuse the resources, Salesforce has applied some governor limits. So in the multi-tenant environment, one bad loop doesn't take on performance for everyone. Code remains scalable, bulk safe. Bulk safe means it works with multiple set of records, and also database and platform resources are protected. So that's why Salesforce has governor limits, and they were applicable per transaction. Transaction means like if you're running a trigger, that's a transaction. So a single unit of work is called as a transaction, and usually when you have governor limits, they have different set of governor limits for asynchronous versus synchronous. For synchronous, the limits is less compared to asynchronous. Okay. So if you want to see what all governor limits you have, so this is the governor limits in Salesforce, and it will basically give you all the different governor limits that are available. So you should know how many governor limits are there for SOQL queries, DML statements, all of this. And you can see here one block is for synchronous, the other one is asynchronous. So total number of SOQL queries issued is per transaction is 100, whereas if you run it's the same thing asynchronously, it is 200. So it's almost double. So that's why it's better to run things asynchronously versus synchronously, because you get a better set of limits. And these are certain what you call governor limits that you have, and you have to be mindful of these limits. Okay, so the important method is how can you hit governor limits? It's very common to hit governor limits if you have bad code. One is when you exceed a limit, Salesforce usually will throw an exception like this called limit exception. So anytime you get a limit exception, that means a governor limit exception was thrown. So here you can say too many SOQL queries. So it'll tell you what caused that governor limit exception. Or it could be too many DML statements. If you have more than 150, that's when you're going to get this. If you have more than 100, you're going to get this limit exception. And CPU timeout, if you're using a lot of nested loops and the processing has increased, then you will get a CPU timeout error as well. Okay. So the most important governor limits that you might come across is SOQL query limits. Means if you are writing a query inside a for loop, so anytime the for loop runs, that query will get executed. So that will result into too many SOQL query. And if let's say you are running a for loop for a list, and that list has 200 records, and you are running a query inside of that, then that query is going to run more than 150 times, because it will actually try to run it for 200, but the exception will be caused at 151. And there is no way you can handle a governor limit exception. You cannot have it try catch and continue with it. It cannot be possible. Okay, you cannot catch a governor limit. Once it is thrown, your program just stops abruptly and you cannot proceed. Okay, so if you are running the inside loops, that is going to cause the what you call governor limits. You can only run a limited number of queries per transaction. If you go exceed, you will get this exception. Even if you don't know the exact number, the rule is always the same. Don't write your queries inside the loops. You basically query it one time. So just you can say here, this is a bad example where inside of this trigger.new, as I mentioned, trigger.new will have newly created set of records, right? So for all those records, it is running this query select ID from contact, and that is going to give you at some point an exception. Similarly, in this case, if you had to do the same thing, what you will do, you will add all those IDs, and then you will do a single query outside of this for loop, and there you will query all the contact records for those accounts. Okay, so here this is a good way of writing the same thing. You're getting the same result. Here you are writing the query inside a for loop. Here you are writing it outside the for loop. Okay, so this is how you can prevent. Another one is SOQL query limits. Basically, you can run a limited number of queries per transaction. Did I have it? Oh, I haven't do it again, probably. Okay. So always remember that. Now there is a limit class that is available to you. So let's go to the limit class, and here you will go to the limit class in Salesforce. Okay, now in this limit class, there are different methods are available. Okay, so the limit class basically, if you want to know the there are two versions of the method. First is to give you the maximum you can run and what is currently you are hitting at. Okay, so let's say the maximum you can do is 150 SOQL queries. So one method will give you what is your limit, and the other method will give you how many you have actually run. Okay, the limit method returns the specific limit for the particular governor, such as number of calls of a method or the amount of heap size. So this particular, the first method returns the amount of resources that has been used, while the second version contains the word limit. So anything that gives you the word limit, that tells you the actual number of resources that are available. And one gives you how many of them you have already consumed. Does that make sense? So let me explain to you one more time. So here you have this one, get async calls and get limit async calls. So get async calls will basically will tell you how many calls you have done, and get limit means what is the maximum number you can do. So when you see the word limit, that means it will give you the what is the limit you have on those. So if I go to the better one, returns the total number of DML statements methods that can be called. So maximum number that you can call, and the get DML will tell you returns the number of DML statements that you have already called. Did you understand the difference? Anything that uses the word limit will give you the total number of records, that means the limit that you have, and get DML will give you without the limit method, without the limit, basically will give you how many you have already crossed. Okay, let me explain you with the help of an example. So here, if I go, there is this class I will create called limits demo. File, new, Apex class, limits demo. And inside of this, I have a method. And inside of that method, okay, so this one will tell me how many SOQL queries I can do. This will tell used before, means get queries means how many I have done. Okay, so let's run this. Okay, I don't know what happened here. Okay. So SOQL, before you hit any SOQL or before you do any DML, you will call this piece of code. So get queries will give you, you haven't done any queries, so it'll be 0. Limit get will tell you what is the limit you have. Similarly, how many DML statements you have actually executed and what is the limit of them. Okay. And here you are performing an SOQL. So means you have consumed one of your limit. Here you have doing a DML, so you have consumed your DML as well. So once you do this, what will be the output of get queries and get DML? So one each, right? You have done one SOQL query and one DML query. So let's go ahead and execute this. So I'll go over to the limits demo. And then here, I'm going to go to the show limits example and let's execute it. So in this case, what happened? Oh. Execute it. And we will go to, oh my God. ACC dot of, I select here, what was it called? And then ACC dot of region, what was it called? North. Okay. Oh. So now if you see here, see, you did not run any query, so it was 0. So the maximum queries that are allowed is 100. Similarly, you didn't run any DML, so it was 0. Maximum DML allowed is 150. Similarly, SOQL queries you ran is 1 and DML statement used is 2. So let's see what happened here. Ideally, it should be only one DML, but for some reason, it is considering it as two DMLs. But anyway, this should give you a better answer. DML statements used after, so 1 and 2. So it basically one method is, so you understood, right? One method is giving you how many you actually consumed. And the one which has the word limit, it is going to give you the maximum you can do. So get limit will give you the maximum number of DML statements. So anytime you are writing your code, you will check, hey, is less than that or not. If it is less than, then only continue with my running the program. Because the moment you become equal, then it's a chance that you're going to hit the governor limit. So in your code, you will check, hey, what is the limit? And is my get DML statement is less than get limit DML statement? And if it is, then keep continuing with the program. So this is how you can use your governor limits. And there are different ways of kind of writing code in which you can hit governor limits. And I've given you different examples where you have written a query inside a for loop, or if you're doing a DML operation, you are doing insert for every account rather than creating a list of accounts and then doing a single DML statements. And then here there is a limit class which you can actually use the methods to tell you how much limit you have already consumed and what is the maximum number you can hit. Okay? Any questions, guys? Okay. So these were the two topics I wanted to cover today. One is the limit class and the other one was your test classes. Tomorrow we will have is the mock layout. If you give me 10 minutes, let me see, you can take a break of 10 minutes and let me see if I can come up with that mock example that is working. That way we can finish the test classes. Will that work for you? Okay, so
Okay.
I will see you in about, right now is 11:24. How about we meet again at 11:40?
Okay.
Okay, so let's do that. I'll connect with you. Okay, guys, can you hear me?
Yes.
Okay, and can you
Yes.
also see my screen?
Yeah.
Okay. So now we will also do, this is an important one, and you will do this quite often, especially when your Apex class is trying to make a call out to another system. So this is one of the API that I was able to find online. It's called Open Weather Map. So if you go over to a website called Open Weather Map here, and basically this website will give you weather, and you just have to create an account with them. It's a free account, and it will give you an API key. Okay. And if you send that API key with every request, you will get a weather for that particular city. So for example, this is a GET request, and this is the endpoint, and I'm passing in London as the city name, and I am passing my API key, and it is going to give me the weather for that particular city. So you can see here, the temperature is 273. Wait a minute. Speed is this, time zone is this. So it kind of gave me certain, I think it is giving me the weather and longitude and latitude. And then what else it gave? Humidity it gave, feels like 269. Temperature is 273. Which parameters is it using? 270 is pretty hard. Let me do Dallas. Let's see if it gives that. 287. Is it? It's not Celsius. Kelvin. Okay. Maybe it's giving it in a whatever the number is. So it's giving you a temperature. It gives you a pressure, minimum temperature, maximum sea level, all this information. So this is the response that is coming from this API. Okay. So when you have to write a test class for a class which is making a call out to an external system like this, you will have to create a mock response. Mock response means a dummy response, because through test classes, you cannot make actual callouts, right? Why do you want to? Because these callouts cost money. Anytime you're making a call out to this system, let's say we're talking to a weather service, now it's going to call, it's a network call, and it's going to cost me money. If I exceed the limit of 1,000 calls in a day, and anytime I reach 1,100 call, I have to pay them. So Salesforce does not allow call outs through test classes. So how do you test those test classes? So what you do is you generally create a dummy response. So instead of what is Salesforce telling you, that, hey, I'm not going to make a call out to the system. I am going to, this is what the Salesforce tells you. So let me pull it up. Salesforce is telling you Apex test methods are not allowed to make real HTTP callouts. Why? Because tests should run in an offline mode. It shouldn't be repeatable, right? Test is repeatable, right? You keep on rerunning your test over and again to test them. And it should not be dependent on external systems, and they should not consume any money, right? Because they should not charge against API limits. So that's why they don't allow callouts to be made through test classes. So how do you do it? If you try to make a call out in a test without a mock, you are going to get a call out exception. So what they are doing is they have introduced something called as HTTP callout mock, is a Salesforce official replacement for real APIs during test. So when instead of actually calling the external system, it is giving you back a mock response. That's why you are saving money by not making unnecessary call out, and you are also testing your test class at the same time. So when you are implementing any class which implements this HTTP callout mock, so this is okay, tell me, is it an interface or is it a class? HTTP callout mock. By looking at this statement, what do you think?
Class.
Interface. It implements, so it's an interface.
Exactly. Extends is class, implements is interface. So when Apex class when you are trying to call an external endpoint through a test class, you are not actually going and making the call out. You are basically getting a fake response. Okay. Now, why do we need a fake response? Because the test class actually does not make the call out. Test class is not supposed to make the call out. Test class will return you a fake dummy response. And that's how you can test it. Okay. So I have a class which is making a call out, do this web service, and it gives me back a response. It gives me back a temperature, humidity, wind, all of that. Whatever I can figure it out from here, that's what it gives me back. Okay. So I have written a let me explain to you the class first. So this is my service that is making the call out. Okay. So when you are creating the Open Weather API, your API key would be different, okay, than my API key. So just you cannot just exactly copy paste this code. You just have to replace it. So if I go here and I go to File, New, Apex class, and this is my Open Weather Map service. Now inside of this, let's see what we are doing. Just like we have been making any HTTP callouts, we are doing that. So here, okay. There was one more annotation that I didn't explain to you, was called test. Wait a minute. Okay. Okay, so test visible means this method is visible for a test class. That's why it's called test visible. Okay, that's all it is. Means this particular method, which is annotated with test visible, it means that any test class will also be able to see this method. Now, inside of this Open Weather Map service, this is the URL I am hitting. Okay, this is my URL, Open Weather Map. As you can see here from Postman also, it is the same Open Weather Map, data 2.5 weather. And then I'm passing in two parameters. One is the API key and the other one is a query parameters, which is the city for which I need the weather information. And the result I have kind of decoded in this form: city, country, temperature in Kelvin, temperature in Celsius, temperature in Fahrenheit, humidity, pressure, description, and wind speed. So this is the result the API is going to give me. And usually if you look at it, own response, if you go here, it gives you back a name. You can see here, it gives you back a weather. So you can see here, that's how you remember how we create the, 1 second. If you remember, it has name, sys, main, weather, and wind. Okay. And this is nothing but main contains of temperature, humidity, and pressure. Weather contains of main and description. So, and wind consists of speed. So basically, they kind of broken down this response. So if you see here, they didn't want coordinates, so they ignored it. So they have weather in there. Then they have main in there. So from the main, they only picked up few things. From wind, they picked up few things. So this is the only pieces of information you want. You created a kind of a class to hold that response. When you do a deserialization, it will actually convert it into this format. Remember the deserialization part, right? So whatever the actual response that is coming from the API, from that actual response, whichever values you want, you created a own response of that. Okay. Main is nothing but consists of temperature, humidity, pressure. You can see that main consists of temperature, humidity, and pressure. Okay, that's exactly what you did. So the same thing, you have it here. Weather consists of main and description. So if you go in here, the weather consists of main and description. You ignored the ID and icon. Okay, so only you picked up the information. So this is basically your response part. Okay, now you have a method called build URL, and that method takes in 3 parameters: city, country code, and API key. So here, all you're doing is checking if the city is present, because all three is important in order to make the call out. If you don't provide it, the call out will fail. Okay, and then what it is doing is from your it is encoding this URL and it is getting you the query parameters, which is city and your country code. So if whatever spaces is there, it's removing that and it is basically encoding that URL. And now this becomes your final URL, base URL, which is nothing but the URL that is provided up here. In that URL, you are passing in the city, which is -q, you're passing in the city, and you're passing in the API key, which you are passing. So basically, you're forming this URL. Okay, this URL pretty much. The Q equals to whatever the city you're passing, and the API key is also constant, and you're passing that. Now, here is the method which is actually making the call out. So here you are creating an HTTP request. This is the URL you are making the call to, set endpoint, okay, which is invoking the build URL method. And inside of the build URL method, you're passing the city, the country code, and the API key. And this is where the request will actually be made and the response will come back. If the response is not 200 or it is greater than 300, then this is the call out exception that will be made. And otherwise, you are deserializing the response that came back into your OWM response, which is nothing but this response, OWM response, okay? So that's the response, you're deserializing it. And then what you're doing is you are pretty much converting this response into a weather result response, okay? So you created an instance of weather result, and from the weather result, you're setting up the temperature in Kelvin, you're setting up the temperature for Celsius, humidity, and all that. So you, from this response, you are formulating an easier response, which is this. Okay. So here you are getting the response back, and that is the response you are sending. Kelvin to Celsius, it converts the Kelvin value to a Celsius value. Similarly, Kelvin to Fahrenheit value, because we are used to seeing values in Celsius and Fahrenheit, but the API doesn't give you in Fahrenheit and Celsius, it is giving you in Kelvin. So we are converting those back into the right numbers. So now if I make a call out, how do I make a call out to this particular thing? I will have to call open weather map service. And this method that I need to invoke is this method, which is get current weather, but I'm going to get an error because I have not listed it as a remote site setting yet. From the type open method does not exist. Get current weather from open weather. Okay, what do you mean by that? I have classes there. Get current weather. Oh, I'm not passing in any parameters. So here I'm going to pass in Dallas. Then I'm going to pass in US. Then I'm going to pass in the API key, which is nothing but at any point you're not following me, please ask questions. And this is my endpoint, and then I'm hitting the execute. It says unauthorized endpoint. I was expecting that. So what I will do, I will go ahead and copy this piece of the puzzle, just the first front portion, and I will go over to remote site settings. And then here is the remote site settings. And in the remote site settings, I'm going to create a new weather API. And this is my endpoint. Hit save. And here we are going to do an execute. And this is going to give me a response. Okay, and let's see, we actually have not captured the response. So what are we going to do? The response is of the type open weather service dot of weather result equals to this. And then here I'm going to call it as result. And here I'm going to say system dot of debug result plus result. So whatever the response that came back, I converted the response into this format and I'm showing that response. So if I do and hit the execute, go to debug, it gives me back the pressure of the city is Celsius is 15, Fahrenheit is 59, which is pretty much 60 degrees right now. Temperature in Kelvin is 288, speed is 6.9. So this actually made the call out and it gave me back a response. But this is from the regular class. Okay, now I have to write a test class for this. So how will I write a test class? Pretty simple. Only thing I need to remember is, just like you have written any other test class, it's the same, but the response will actually be a mock response. So it's not gonna give you back, the call out won't be made through a test class. So how will your test class looks like? Test class will look something like this. So before I jump to the test class, did everybody understood how did we make the call out from the weather map service? Guys? I got a thumbs up from Shalini, Manisha, Linda, Hema, Gayatri, what about you? Okay. Very good. So simple one, right? So I got a response. Basically from my this, I converted into a own response, and then this own response, I converted into a weather result, just to make things simpler to see. Now, in order for me to write a test class, all I need to do is everything will be same. So this is my open weather map service test. Okay, file, new, Apex class, open weather service test. And here I'm going to define my test class. Okay. So inside of this, let's understand. So this open weather service test is a test class for my open weather map service. And here inside of this, I created a successful mock. Okay, the response. So here I'm checking the endpoint. You don't have to do this because you're not actually making the call. So when you do this one, actually the call hasn't been made to anywhere. See, here is just creating a response. We're not doing http.send or anything at this point. So this is a successful response. So this is the response that came back. And if you see here, this response similarly matches to this response. Okay, they didn't copy the whole thing. They copied a little bit of it, minimalistic, realistic JSON from open weather map. So this is the response. And that is the response they have implemented it HTTP callout mock. So when the callout will be made, the actual callout will not be made, but this is the response that callout will give you back. Similarly, it created a failure response. You don't have to do that, but this is a mock of the failure that, okay, it's going to give you a 401 error. Message would be invalid API key, which it does give if you provide an invalid key. And one more thing, guys, open weather API, it generates an API key, but that API key at least will not work for first 2-3 hours. So once you have generated it, you have to wait at least 2 hours before the API key becomes active. It does tell you that, okay? So don't come complaining, oh, that is not working. It took me at least 2 hours to get that API key working, okay? So then here you're checking the get current weather. So when you're doing this, so this is your test class, you're setting up the mock, you're telling that, okay, I am making a call out, but that call out is through the test class. So the call out will not be made, but this is the response that it should give me back. And here get current weather this is the method that will be called, which is actually making the call out, but the call out is not being made, right? So it's giving you back this response, HTTP call out response. And then you're using the assert statements to check, is the city London? Because see here, your mock response has London in there, country is GB, Great Britain, temperature is 280. So now you can do, because that's what your mock response is. So now you can do your assert statements to check it. Okay. Similarly, they created for the failed response also. If the API key was invalid or something, you get a failed mock response. So you have a the same mock response for a failed output. So that's what it gets called. So one is for a successful response, other one is for a failed response. And you are basically not making the call out to the system, but you are basically saying that if the call out would be mailed and if it's successful, this is the response should look like, this is a success response and this is a failed response. The only learning point you have to remember is implementing the HTTP mock call out interface. That is the one you have to remember. HTTP call out mock, that is the interface you have to that is the interface you have to implement. And when you are, because through the test class, you cannot make the call outs to the external system. So you have to mock the response. And if you run this test now, test new run, HTTP, these are the 3 methods it has, and run here, you will see all the test methods will be passed. So if I go here, you can see this is your test methods. These all passed. And if you go to the open weather class, this is yours and it has 100% coverage. So anytime you have to write a test class for a class which is making the call out, you have to remember to mock the response. Okay. And in the beginning, you set up the response in the beginning, and then you call the class which is doing the call out. So it knows that not to make the call out, but use the mock response. Any questions, guys? Okay. So with this, our class for today is over. We will meet tomorrow. And hopefully with tomorrow's should be the last class. And I will be covering dynamic test Apex classes. So that is important. Um, uh, I'll try my best to cover it, but I don't think I probably have covered at least 90% of your Apex syllabus. There might be few things here and there that might have been skipped, but you are in a good shape. If you have gone through all the examples, done the assignments, you are good to at least pass your Platform Developer 1 exam. Okay. Platform Developer 1 does test your knowledge on admin. So we are not covering the admin portion, but the development portion has been successfully covered. So if you have any questions, let me know if there is anything. So I'm hoping to finish it by tomorrow. Don't want to extend it after tomorrow because we have already done so much time we have taken for this class.
So, Deepika, I just want to register for LWC classes. So from next week onwards, the classes.
So the next, yes. So LWC class will be starting the week of 10th. So you will have this whole week, but I will recommend you to enroll early so that we know how many students are expected for that class.
Okay, sure.
Okay. And the other thing is, you know how to enroll it. It's pretty simple. You go to MyTutorialRack and you just go to the over here, not here. Go to the live training and then just select the LWC portion and enroll from there. Reserve my seat and just enroll the LWC. It's $249 and you can do that.
Sure.
Okay. So tomorrow will be the last class. And if you guys have questions, if you want to, because we will be doing these developer batches, if you want to join a new one, feel free to join that. I hope you don't have to if you have taken all these classes. And any questions, you can just let me know. Okay.
So we'll keep all the YouTube videos, right?
What is it?
I mean, like all the class videos in YouTube, right?
Yes, everything is on YouTube. Today's will be posted as well, but yeah.
Could you please do it for the last week also? You just shared the Zoom.
Did I not put it on this? I believe
Yeah,
I
one
did.
from the 21st, I think, is.
I think I did it. I did.
Okay.
Please share the link. We don't have that one.
Let me see. I did it.
And also the PPT.
That I'll do it.
The web services and couple of them are missing.
Okay, I'll do that. So here, let me just, if you wait on, I'll do it. So here we covered the playlist is weekday and developer is this one. Videos. What did we cover last time? We covered integration, right? So that I did uploaded it.
Platform events and recursion and those things.
Oh, yeah. So that one is missing. Okay, I'll upload that. And then, guys, please, if you don't mind, if you can take literally 2 minutes of your time, either you can post a Google review, very simple, go to MyTutorialRack, post a review. That way I know how I did. And if you can't post it to the Google review, if you go over to the consultation, there is the reviews over here. So if you scroll down, you will be able to upload a review through this tab. So if you go to the reviews, you can scroll down, put your review from here also if you can't find a Google review.
Okay.
Okay.
Deepika, what day of the week is the LWC going to be on? Saturday?
It'll be on the same weekend, Saturday, Sunday.
Okay, thank you.
Is it same time or we are starting early?
I have to talk to the instructor. I believe it is 10 to 12, but I will let you guys know. Maybe Monday. Give me till Monday. I'll let you know.
Please try to make it early if possible.
Okay, I'll see because the instructor also has to be available.
Mm-hmm.
Yeah, this time works better for us. For me, I'm on Northwest.
Okay.
Any other project we are getting, Deepika, for this development class?
For like assignments for the week?
Overall, a project.
Yes, I will provide you by Monday because I have to sit through and give you an assignment to do it.
Not
But
assignment,
even if
take
you
your time for the project, but a complete project where, we can
All
showcase
these
it.
topics are
For
covered.
the
So we
resume also we can showcase a project, mini project
But
type.
see, the mini projects, those will be because see, LWC has to be covered for that because
Yes,
LWC
okay.
is the front portion. I
Right.
have covered all the back end portion. Like you can start with the flow. Remember that flow one we did
Yes,
where
we
so
did
that's
that.
one project, kind of like an end-to-end feel. But from LWC, you will be able to connect the dots together.
Okay.
Okay. So I will also I'll also talk to the instructor and ask him to give you more LWC mini projects where he will be able to give you the UI part and you can add your own complexity to it by building the backend portion.
Okay.
Okay.
Yeah.
So that is it for today, guys. And if you have any feedback, let me know. If there is anything I can improve on, just send me a message.
Sure.
Okay. Thank you, guys. I'll talk to you tomorrow.
Thank you.
Thank you.
Bye.
Bye.